Okay, now that we have a functioning PowerUp, we'll have to find a way to display the PowerUp meter so we can see how much juice we have and so on. So let's start by creating a new game object, calling it HUD for heads up display. So HUD. And we'll also want to attach a script called heads up display. Let's do that. Let's open it up. And in this script, we will just want to output, a simple user interface text. So instead of using the update method, we'll instead use the OnGUI method that's also part of Unity Engine, and use the GUI class to create a label for the text. And so I'm going to read here from the official Unity documentation the definition of OnGUI, so we kind of have a working definition to start off with. OnGUI is called for rendering and handling GUI events. This means that your OnGUI implementation might be called several times per frame, one call per event. For more information on GUI events, see the event reference. If the mono behavior's enabled property is set to false, OnGUI will not be called. Alright, so basically OnGUI is run in a loop, very similar to the update method, but not so tightly bound to the same one call per frame sort of specification of the update method. But otherwise, it looks like it'll be a good place to put our event-based UI stuff if we had them, like buttons and menus and that kind of stuff. So we don't really have that right now, but it looks like OnGUI will also serve us well to output our text labels with some of our HUD information. So we can go about creating the label in OnGUI by calling the static label method found in the GUI class. We're not going to need that, so just write in void OnGUI. Actually, it's all capital GUI, GUI. So I made a mistake with that and didn't realize why it wasn't working. So simply reference the GUI class and the label method, and let's go up and down to see the different options available to us. Kind of try to make some sense out of this. Now, the fact that we can access different versions of methods is something we haven't really talked about yet, but you've probably already noticed the option of accessing seemingly different versions of the same basic method. This is part of a C# concept called overloaded methods, or method overloading. We've seen this many times on the calling side, as I would say most of the methods defined in Unity have several different definitions that accept different input parameters, right? But we haven't seen how method overloading works on the definition side of the equation. So simply put, method overloading is creating several versions of the same method, same in that it has the same name, at least, but the implementation details are perhaps different in some way. But the obvious question is, how does the compiler know how to tell them apart if they all have the same name? Well, the answer is that the method signature is what the compiler really looks at to differentiate these similarly or same name methods. So as long as the method signatures are different, in particular the amount and type of input parameters, the types used in other words, it's considered a different method by the compiler, although nonetheless grouped in with the other methods of the same name for convenience, for example when accessing IntelliSense. So let's demonstrate really quickly how you can do this by going back to one of our test scripts and writing in an overloaded method definition. So I want to go to the class person class, and let's just create an overloaded definition of this doAging method. Really easy. Just go public void doAging, so it shares the same name, and we'll differentiate this one with a different method signature as the original empty input parameter version, say amount. Now the important part here is the type in the input parameters, or the lack thereof for this one, in differentiating these two methods and therefore being overloaded. The identifier, the name for the local variable, it doesn't have an impact on this method signature, right? Neither does the return type. So it's basically the amount and the types of the input parameters. So if I had a third method called doAging and I had a string p, whatever, that would also be a valid third overload method. So just sticking to one overload method just to demonstrate this, let's just go, this would be how maybe the implementation details might differ with the different versions of the method. So this is pretty intuitive, I think. So if we go to the person factory class, right, it doesn't really matter where, we're not gonna actually keep this, but just for demonstration's sake, let's call, from either one of our instances the doAging method, and then there you go. With IntelliSense, it gives us the option, either one with a single integer input parameter or no input parameter, right? And so if we put that in there, it will know that we're referring to the second overload method, the one we just created. All right, so I can run this, but I'm pretty sure you know what will happen. Let's get rid of this right here. But we probably won't be making many overloaded methods, or maybe any at all, for this project. But I thought it was something that you should know, having come to see all these overloaded methods that Unity provides. Unity has a lot of overloaded methods that it hands over to you, and it's just worth knowing how this works in the background. So now, having understood overloaded methods, let's see what kinds of label methods we have at our disposal and try to better understand how to work with it. So back up to heads up display. I'm just gonna get rid of these, don't need them right away. All right, so let's go through these up and down on my keyboard here. Let's see if there's anything familiar we can work with. I see something called a rect and some string inputs. I think this second one's probably good to start because it's really simple. All we need to do is just output some text. So it takes in a rect called position locally to this method and a string. So all we really need is just a section of the screen where we output our PowerUp meter integer. So we can just convert that to a string easily. So I think this method will do. But another thing that pops out at us is we need a rect. What's a rect? I don't really know. Well, I mean, I've used this before, so I kind of know, but so let's just do what's most obvious when exploring. Let's type in new rect and see if its constructor can give us any hints when trying to formulate our label call here with something useful, when trying to figure out what a label takes in as input arguments. So let's say new rect, and through IntelliSense, see what the constructors give us. All right, yeah, so this looks familiar. An x, y floats, as well as width and height, creates a new rectangle. So this is something familiar to us, an XY position on the screen, in other words, that also asks for the screen's width and height. So all floats, this is familiar to us. So let's try this. Let's say X15, whatever that position means on the screen, and 15 for the Y. So I think that'll be in the upper left-hand corner. And let's pass in the width of our screen, which is available through a property called width. Right, that's a float. And screen height for the height. And for the string, let's just type nothing particular and just say test. Let's just see how this works. And well, so again, I'm going to use this odd way of creating a method call just on different lines here. So the first argument is here, separated by a comma is the second argument, and then the right parenthesis on its own line with the semicolon termination. So this should hopefully give us an output that says test in the upper left-hand corner, if we're understanding this right. So let's just run this, save that, and I think it's about time we disable the sphere here, because we don't really want to, the script, in other words, it just sort of gets out of our way. So we just want to test out what we're doing. And I never did put the script on the HUD, so of course do that. And let's see what's going to output here. I can barely make it out. I think there's something there. I guess it looks like there's the color clashing. It appears as though it's defaulting to a white text. All right, so if you want to change the color of your text, I mean, I'm not going to worry too much about how the text appears. We're just going to keep it really simple to output information to the screen. But here's an easy way on how you can change the text color. Go back here, and right here in the OnGUI method, we'll just say GUI reference the class and content color, and we'll assign to it a color. Sorry, before I do that, I'll just hover over this. See, it's a color, it's a type color, so we're going to need to give it a color. See what's available to us. I don't know, I'll just make it blue. All right, that should stand out. And now let's run it. Let's see if it's working. All right, great. Looks like it works. So the next thing we want to do is replace this temporary dummy text with our actual PowerUp meter. So let's go back here, and instead of test, we'll write in, so we know what we're referencing, PowerUp, and we'll concatenate that with the PowerUp manager dot PowerUp meter, which is, what is it again? It's an integer, right? So this is supposed to be a string. Well, apparently this will work, right? It will implicitly convert it from an integer to a string. But in other cases where it's not implicitly converted, there's a very handy method available to the integer class, so all integers in other words, called toString. So I'm just going to call that at the end to make sure it returns a string, right? So let's try that. Yep, great, looks like it's working. All right, that's pretty good, but I think we can add a bit of HTML-like markup and, you know, bold this text and make it a little bit more interesting. So let's wrap it in bold type tags. And well, this is going to look a little bit funny with all these concatenations and whatnot. So let's just go back to, let's use the string format method that we used before. So bold it first with a bold tag. And we'll want to have the placeholder for the first argument here, which will be the PowerUp meter. And I'm doing this kind of in a funny way. Don't get too put off by my choice here. And all right, there we go. I'll just keep that on one long line because otherwise it's going to look even uglier. But otherwise it should work. Yep, just a little bit bolder. All right, so now that we have the PowerUp there, why don't we add the cooldown meter to the GUI as well, right? So we'll probably want to see that value because otherwise we won't know if we're cooled down or not. So let's just do this. Let's just pretty much copy this right here. And we'll make this below on the Y coordinate, say 35 for that. And we'll say cooldown. And then for that, we'll want to reference the cube controller's cooldown, which, let's see, was it static? I don't believe so. We'll have to make it static. Oh, it's not. So let's just make it static. Then here, we'll say cube controller dot cool counter, and then again we'll append, because it's an integer, the toString. just to make sure, just to be explicit about it. I'm showing you that more so that when you do see that, you're not confused. It's not often used in Unity, but it's a useful conversion method nonetheless. All right, so everything looks like it's pretty good here. Let's just run this really quickly and see how the cooldown works. First, I'll let the PowerUp count down. Yep, and the cooldown. It's also working well. Awesome. All right, well, now that we have all this information outputting to our HUD of sorts, we can now clean up all these debug log references because we don't really need those. So here's a little handy way of doing that. You can just, with Control F, anywhere here in Visual Studio, we can try to search for the entire solution for references to the debug log. All right, so here I'll say entire solution, and there, we don't need that anymore. And the PowerUp Manager, we don't need that either. I think that's all we're really looking for right now. Save that. Make sure it's all saved. All right, now that we've effectively created some sort of UI display here, we can always come back later to this script whenever we want to output some more information. I think later on down the line we'll want to create a scoreboard, for instance. But for now, I think that's in a good state, and we'll move on to solving more problems in the next video. I'll see you there.